All right, everyone, we are moving on to the third page of our Ferris Wheel of Doom investigation. So here we're taking a look at this scenario if our car is to get stuck at any given angle here. Okay, here our angle is 30 degrees. And if our car gets stuck, we want to know what the gradient of the arm is at that point. So imagine we're in the car here and it gets stuck. And now we need to climb down here, right, to get to our safety boat that we had there in the middle, right? So we want to know what is the gradient of the arm that we're going to be climbing on this Ferris Wheel of Doom. Okay, so that's what we're taking a look at today. So go ahead and pause the video and answer questions 1 through 6. Okay, and you'll have to put a few of the questions into the Ed Puzzle video as well. So go ahead and do that, and then once you have those answered, go ahead and start the video again. Okay, so taking a look at our Ferris Wheel of Doom, answering questions 1 through 3 first. Which two angles is the gradient of the arm 1? Now, we have kind of taken a look at this before because we asked at what two angles do we have the same horizontal distance and vertical height, right? And we determined that to be 45 degrees, 45 degrees as well as 45 degrees and 225 degrees. So 45 degrees is somewhere around here, and 225 is somewhere around there, right? Okay, so those angles are going to give us the same distance, okay, horizontally as vertically. Okay, now in quadrant 1, both of those distances and the distance and height are going to be positive. And in quadrant 3 here, the distance, the horizontal distance and vertical height are both negative, in which case we have a gradient of 1. So for number 2, we're going to be working in quadrants 2 and 4. 2 and 4 there, because again, we're going to go at the 45s here. Okay, so when I go there and there, okay, we have this sort of same triangle that I drew here on the third quadrant. It's just mirrored in each one of our quadrants. Okay. Now in quadrants 2 and 4, the signs of my distance and my height are the opposite, but the values are the same. So that's how we get a gradient of -1, and those angles are at 135 and at 315 degrees. We're working it in degrees here. Okay, answering number 3, what happens to the gradient as it gets closer to 90? So as my angle starts off here at 0 and starts working its way to 90, okay, well, at 0, or at a really, really small angle, okay, something like that, our gradient, I think we can see, is it's positive, but it's really small, right? It's really shallow. Okay, and then if I go to a really large angle, think about 88 degrees, something like that. That's a really, really steep gradient, right? So hopefully we answered for number 3, something along the lines of our gradient gets larger, or you could say gets steeper, or something along those lines there. Okay, gradient gets larger or steeper. All right, taking a look at number 4, filling in our table here. So for 15 degrees, I got and it says proportion of max distance, but we're looking at our gradient, right? So that's going to be 0.27. And then for 60, I have 1.73. And notice at 90 degrees, we actually have an undefined value, right? Because at 90 degrees, we are straight up and down here. Okay, at 90 degrees, we're there to there, right? Now, a straight up and down line, we actually don't have a gradient, right? That is going to be undefined for us. Okay, so for 90, we are undefined, so we're leaving that as is. At 120, I have -1.73. At 150, -0.577. 180, I'm at 0, because at 180, again, we are at here at this sort of horizontal line. Okay, gradient of a horizontal line is 0. 210, 0.577. We can start to see some patterns here. At 225, I'm at 1, like we said. At 1.73, at 240. Again, at 270, I have a vertical line, right? So I don't have any gradient that's going to be undefined. And then I'm at negative 1.73 here and negative 0.577 there. Now, if you go ahead and graph all of those, hopefully your graph looks something like this. Okay, now it's quite different from what our sine and our cosine graphs look like. Okay, notice here we have these asymptotes. Okay, asymptotes at negative 90 and positive 90. And then we see those asymptotes repeated every 180 degrees from there. Okay, so at negative 270 and positive 270. All right, so when you are graphing a tangent function, it's often really, really helpful to graph those asymptotes first, and then you can sketch the shape as afterwards. Okay, also notice that here, as I cut in half the distance from where my tangent graph intersects the horizontal axis. Okay, if I cut that distance in half with the vertical axis, or with the vertical asymptote here, all right, that's going to be at 45. So that's going to be right about there. Okay, at that halfway point, okay, that is where we have the value of 1. So again, at the halfway point going the other way, that's where we have our value of negative 1. Okay, so that's going to be helpful when we start to graph function transformations, which you'll be doing later on. Okay, all right, so taking a look at number 7. Okay, so really what we've done in these past 3 classes with this investigation is we've introduced ourselves to these 3 trigonometric functions. Now, we've done it in the context of this circle. However, there doesn't have to be a circle for us to use these trigonometric functions. So if I have any right triangle, okay, like so, where this is our right angle, and we'll say that this is going to be angle theta there. Okay, so if that is my angle theta, then the side opposite, okay, that's what we're going to call opposite here. Same as what we see in these formula. Okay, the side adjacent means next to, right? So the side that is connecting this angle here with our hypotenuse is going to be the adjacent side. So adjacent there, and that's going to be the adjacent that you see in the cosine formula. Okay, and then our hypotenuse is the same as what we've been working with right triangles in the past. Okay, so this is how we would label our sides. And this is really what we've been doing in terms of this Ferris wheel investigation, is I've been looking at these triangles, right triangles, inside of this circle. But again, if I take the circle away, the relationships still stand true, okay? And we can still calculate sine, cosine, and tangent values for right triangles using these 3 relations, okay? All right, so we've seen some of the graphs for our trigonometric functions. So next thing we're going to do is pause the video, and we are going to be taking a look at this link here. Okay, so go find the PDF of our investigation, click on that link, and have a little play with the with transforming our sine, cosine, and trig functions. Once you do that, it asks you to write a short report or short record of your findings. So that's going to be on. We'll put that on our Lucid Spark dashboard. Okay, so I will put a link out to that. So once you have written your short report, okay, doesn't have to be like multiple pages, right? But just something that kind of shows how these transformations, function transformations, are affecting if you have a y equals sine x, right? And I transform that to be y equals sine of 2x, okay? What happens? Or if I transform that to y equals 2 sine of x, what happens to that sine graph? Okay, so those are the types of discussions I want to see in those short reports of our findings, okay? So pause the video, have a play on the GeoGebra link, and we'll resume in a bit. Alrighty, so hopefully you were able to find some patterns, right, with your function transformations in terms of sine, cosine, and tangent. Okay, it's very similar to what we've seen in the past, right? I'll have y equals a sine b parentheses x minus h plus k. All right, so hopefully we're able to kind of see that this a value, okay, that's going to be our sort of amplitude. That tells me if I have a sine function that looks like this or a sine function that looks like this, okay? How much is that vertically stretching my minimum and maximum points there, okay? So that's what that a value is going to do. The b value does something similar, except it's going to take our sine function and it's going to potentially stretch it, right, to be a little bit longer. So it's going to take these points here and it's going to stretch everything in the horizontal direction, right? That's what that b is doing. And then h and k, very similar to our other function transformations. If that is what sine looks like, and I say sine plus k, so that is going to shift up, right, k units, up k units. So k shifts me up, and then h shifts me left or right, okay? All right, so that is hopefully what we were able to find with the GeoGebra link. If not, I'll post some more video resources for you as well there. All right, so now what I'd like us to do is pause the video, and for A through H, I want us to find possible functions of these graphs, these 8 graphs below, okay? Hint, hint, sine and cosine are very closely related, okay? So see if you can't express some of these functions in terms of both sine and cosine, okay? So pause the video, find your answers, and then we'll continue in a bit. All right, so going through some answers that I got for A through H. So these are some possible answers. These aren't all the possible answers. So you may have got something different. Go ahead and check on, say, Desmos or your graphing, your GDC, okay, if you got something different. Okay, so for the first one, we definitely have an amplitude of 2. So I have 2 cosine x. I also put 2 sine x plus 90. So hopefully you can see that if you were to shift your cosine graph 90 degrees, you actually end up with what looks like a sine graph. Okay, so important to realize that. All right, so for part B, sine of x and close parentheses plus 1, or y equals cosine x minus 90 plus 1. Okay. See, this is our one tangent graph. I just wrote 1 for this one, so I said tangent of x minus 30 degrees. Tangent x minus 30 degrees. And for D, I wrote y is equal to sine of 2x, and y is equal to cosine 2 parentheses x minus 45. So notice, because I have this 2 here, this shift of, I said earlier that you have to shift 90 degrees in order to change cosine to sine, or likewise, or reverse. However, because of this 2, right, that is going to affect what is in our parentheses there. Alrighty then, for part E, I wrote y is equal to sine 2 parentheses x minus 45. Okay. For f, y is equal to 3 cosine x minus 30. For g, y is equal to 1/2 sine of x plus 1. And for h, y is equal to sine 2 parentheses x plus 15. And y is equal to cosine. If we were to write this as a cosine, I would say 2 parentheses x minus 30. Okay? Okay, so again, these are some of the answers for these trigonometric functions. If you got something different, again, check it on your GDC or on Desmos. But that is it for today.